Hey everybody, how's it going? Our House 21 here, and this is the conclusion of my bearing swap video series. So just to give a recap of what I've been doing here. A while ago I got a set of ceramic bearings from the good people at Boca Bearings who wanted me to do a benchmark to compare the performance of stock Traxxas bearings, which are these guys right here, the nice blue seals, and actually these are, if I don't drop things, these are actually pretty nice bearings that you get. Nice sealed units, but definitely room for improvement. And they sent me a set of their yellow ceramic bearings. And I would show you them, but they're in the car now. So, along with that Boca, they were nice enough to give me this little cheat sheet that has popular bearing sizes, and you can use that to basically help to identify individual bearings and that sort of thing. So, good stuff. Check them out. But as I said, the point here was to be able to try to get some good quantitative data that says, do these ceramic bearings make a difference or not? So in my previous video, I did a run-up with this test configuration with Dizzy, with the stock bearings in. I took it to the max RPM, a gradual run-up, so I didn't pull a lot of extra current transients or pull extra juice just for a spike. So I tried to make it nice and clean, and I'm about to repeat the same test using the new ceramic bearings. Now I will give a caveat. There is a small experimental difference, and I'll see if I can zoom in on this to show you. But basically, this was a leftover from Dizzy's days as a basher before I built Scratch, where if you look on the slashes, they have this little hole here, and I'll see if you can see it pretty well. But there's this little hole through the chassis where the drive shaft goes, and that is a notorious place for dirt, crud, and all sorts of mess to get inside the chassis. So I had a little piece of Velcro, the loopy side, that was up against the drive shaft in the hole here to help to block crud from getting in. And that was really important when this truck was a truck and it was going out and bashing around in the dirt. Now that it's an on-the-road configuration, that's not really that important. And I forgot to take it off before I did the first clean run-up. So I don't think that the total difference is going to be very large. However, it could be large enough to give me slightly skewed data. I'm just throwing that out there. A good scientist, lets you know the differences in the experiment and everything. But all that being said, that configuration was very well worn in. I think that any drag that I was really causing was already burned off. So I think that the new run-up should be pretty clean. And I actually did a run-up previously with my Venom battery just to check everything out. And I did see a little higher numbers than I expected, but I think that I was also just breaking everything in. So now I've run it at high speed with the Venom battery. Everything seems to be nice and loose. And so let's go ahead and see what it does. All right. Now, okay, everything's lined up. This should be interesting. stop and do a quick check. So I'm just going to check some temps. So first got the motor temperature, 116 volt on 116 degrees. So it's barely even warm. ESC's temperature is 79 degrees. It's not really thinking that much is going on, which it shouldn't. It's only pushing 250 amp or 250 watts. Okay, so that's kind of cool. The spur temperature is 157 degrees, and the pinion temperature is 182 degrees. So that's actually kind of in line. Okay, let me get it again. Okay, I got 185 that time. Try pinion one more time. 154. Okay, so everything's looking pretty good. So barely getting worn off the battery. Okay, so it looks like I pulled a maximum of 23 amps. So I'm just going to go ahead and keep running up. It looked like basically the power dissipation was hovering right around 250 watts, which is lower than last time. Last time it was hovering at just about 265, if I remember correctly. I have to double check off the video. But again, don't want to draw any early conclusions. Alright, so now I'm just going to go ahead and run it up and keep it sustained and watch how it goes as the voltage drops, just like I did last time. And I'm going to stop when I get to around 3.8 volts per cell. So I've got a little bit to go. You can see on the meter here, all the cells are hovering at about 4.1 volts, which is nice. Alright, so let's go ahead and spin this bad boy back up. Okay. So I'm only pulling 20 amps roughly out of the pack, and it's voltage is falling nice and gradually. So I see I'm at 3.9 volts per cell right now. So I'm going to go ahead and pull it out more until it indicates about 3.7, which means that when I take it off, it's going to relax back to about 3.8, which is a good storage voltage. So let's go ahead and just run it a little bit more. Alrighty, that was interesting. So looks like the voltage is relaxing back to 3.8 per cell. It looks like from a current point of view and everything. So let's check this here. So 183 for the spur. $216 for the pinion. So yeah, they're getting kind of hot. That's 206. Or here's 208. 181. Okay, so that is much more of a torture test as far as RPMs than you would see in the field. Although in the field it will be under load, so that would be a little bit different. So it cause more friction. But all in all, I mean, looking at the voltages, just how they were changing, it's not that bad.
So I crunched the numbers, and I got some pretty interesting results here. And yeah, I used the word interesting a lot, but don't worry about that. All right, so here I have data from the 3 trials. And just to review, I had bearing benchmarking number 1, where I went through and took data with the SMC battery with the stock bearings. Over here, this was the break-in run that was over in the the Boca bearing swap video series. And over here, this is the data set that came from the bearing benchmarking number 2 video, which you're currently watching. And just to tell you what I did, I actually reviewed the raw video and freeze framed at regular increments going down the line as the voltage dropped, and recorded the voltage and the amperage, and I also recorded what the voltage meter recorded as what the power dissipation was. And I had Excel calculate based upon these 2 numbers what it should be, because that's just a quick and easy just a check to make sure that I didn't transcribe the numbers wrong, and everything agrees. So within a couple decimal places, so everything's good from that point of view. Also, because I know what the kV rating is of the motor, because I use my little secret castle trick to characterize the motors using the ESC, I could easily convert from measured voltage into motor RPM. That allowed me to make a plot of what the actual mechanical drag was at any given RPM going up the curve with the stock bearings, and with the Boca bearings. So that being said, let me go ahead and bring up the graph and show you the results. Now, just to help you to read this, so on this axis, I have the motor RPM. On this axis over here, this is the measured power dissipation. So this is what the mechanical drag that I measured along the system was. And the three plots are Boca ceramic bearings, stock steel bearings, and this is for the break-in run. So just talking about the break-in run really quickly, this is, you'd expect this where, I'm using a less stout battery pack. So once it sees a load, it's going to not go to as high an RPM. That's why I can't really use this data to really talk about the measurement. But you see that it's actually going through a break-in process, because when I initially put some voltage on, it starts off fairly low RPM, then it actually creeps up in RPM, meaning that the resistance is actually getting less. Then it just plateaus here and hung out for a while. Then when I took my temperature measurements and went back in, you saw it went down to a much lower level, which is good. So looking over here at the stock bearings, this was a surprising result, because bearings typically, they typically are independent of RPM, or they're supposed to be independent of RPM for the load that you get to the first order. But this is really linear, going all the way from down to storage voltage all the way up the line. So I was able to go in and predict, based upon this linear curve, how much energy would I be saving if I actually took the stock bearings up to this higher RPM that I got with the Boca bearings. And I think I got to the stock RPM with the Boca bearings just because they saw so much less drag. So if you look here, this is significant. The Boca bearings went up to 32,000 RPM, and the drag mechanical drag was pretty much stable at that higher level. Then I pulled voltage, I stopped the trial, took some temperature measurements, and ran it back up. And it looked like the drag just leveled off at the high level, and then just stayed constant going all the way back down the line until I stopped to take more measurements. And then when I got back on it, it went up to a certain level and then stayed flat again. So I'm thinking that this level that it went to is dependent upon, what is depending upon the maximum RPM that you run it up to. But then it just kind of hung out at that same resistance level, and it didn't really go down too much. So, just looking at some quick comparisons over here, I just looked at the stock versus Boca bearings at different RPMs, and the data down at the low end is a little inconclusive, I think, just because we're talking about comparing things down in here. But from 2950 or 29,500 RPM all the way up to 32,000 RPM, you start to see some pretty significant variances, or I should say some pretty significant savings from the Boca bearings, to where if you extrapolate all the way up to here on the curve, we're talking about potentially a 20% reduction in mechanical drag. Now this is extrapolated data, so really the valid measured data is down here around 31,000 RPM. But even then, we're talking about roughly a 12% measured improvement in mechanical drag based upon using the Boca bearings. Now, is that huge? I mean, it's not tremendous, because we're talking about differences of about 20 to 30 watts out of power systems that can handle between 1 and 2 and maybe even 3 or 4 kilowatts. But a measurable difference is a measurable difference. So these bearings are more efficient than the stock steel bearings. But the other thing that ceramic bearings have that steel bearings don't is that ceramic bearings are essentially corrosion resistant, because they're not steel. They don't rust. Other things, the ceramic balls and the bearings are actually harder than steel, so that gives them extra durability. They don't wear out as quickly. The downside, though, is that ceramic bearings are often brittle, so they can't necessarily take the same shock loads that steel does. So if you're planning to use these for a basher configuration or for a hardcore racer, that might not be the best option for you, because you have a higher chance of the bearings just shattering under a crazy abuse. But if you're doing an on-road configuration, or you're doing something where you are willing to accept the risk, you might the ceramic bearings might actually work out really well for you. And I think that Boca does have a more durable ceramic bearing that may be more tuned for an off-road or racing application anyway. So sorry to swamp you guys with tons of data, but I find this, kind of a fascinating result. So again, going in, I was skeptical whether I'd even be able to measure any kind of a difference, but clearly it's in the numbers, and these Boca ceramic bearings are doing something. Now, it also could be that the steel numbers might be skewed because they are older and they are a little worn, but still, the data's there. There's something to the ceramic bearings, and I'm pretty pleased that I was able to have an experiment that at least is a positive indicator that these things are actually worth the savings. Now, if that translates into a difference in top speed, is still yet to be proven. But hopefully here, once the weather gets better and I'm done with my Skunk Works modification to Dizzy, we'll all find out together. So thanks guys for your indulgence in this. I actually had a great time doing this experiment and doing these videos. So just remember to like, comment, subscribe. Let me know what you think. Let me know if you'd like to see some more stuff like this, or if you have some other things you want me to dig into. Also, don't forget to check me out on Facebook, and I'm even started Instagramming a little bit. I'm still not really fully invested in that. So guys, I hope you like this little excursion into the land of bearingness. And I actually had one more one more video planned, but I think I might hold off on that a little bit later. And I was basically just digging into tribology, which is the study of bearings and lubrication and all sorts of other stuff. But I think that's more of a 201 level subject. So as always, guys, remember to like, comment, subscribe. Thanks for indulging me with this. I had a great time doing it, like I said before, and I think that this is a pretty good product, and I definitely get my seal of approval. So as I said, remember to like, comment, subscribe, and as always, remember to get out there, break it, fix it, and do it all over again. This is our host 21 signing off, and until next time, guys, peace.